One of the things that I love about this technology, and I've said it on Facebook and I'll say it again. I always feel like I'm a doctor when I'm doing this stuff. And what I said on Facebook was really, I feel like I'm a doctor in clinical trials. You have this theory of what's going on. You've read somebody else's theory of what's going on. You believe this is the way things are going on, and then you start doing your clinical trials. And then all kinds of weird stuff starts to happen. You start poking holes to those theories. You read something, then you do some labs, and you realize that what you're reading isn't 100% accurate. Now, at this point, you can actually believe your lab, or you can just go off and just just accept the fact that either you don't 100% know, or the fact that you're just going to feel that the documentation is just wrong and that's just the way it is. And some of the stuff that could cause you issues, especially if you start posting things online, and you're so sure of this not working the way it is because you've labbed it, and that was the output you came. And if you start really harping on that, you could come back with with your foot in your mouth. So one of the things that I would like to discuss, and as I'm creating some CCNP level layer 2 information, I came across this interesting statement that was in a book. Frames belonging to this VLAN, now this VLAN will be the native VLAN that we're talking about, are not encapsulated with any tagging information, as if the trunk line was not being used. Now this is interesting because everyone says 100% that if my VLAN if my native VLAN is VLAN 10, that means any traffic that's going across the trunk that is in VLAN 10, guess what? It's not going to be tagged. So then you go out and you lab, okay? And you start wondering how you'll be able to see the VLAN, the 802.1q traffic. So you finally figure out how to do this with your Cisco switches and your spanning. And replicate is the actual keyword you want to do after your spanning destination, your session destination. And once you start seeing that VLAN traffic, you start to say, okay, now I know for a fact when data's going across here, as I'm looking at here, as I'm looking at with this being my VLAN 10 or my VLAN 1, I know that I have traffic going across this trunk. Now let's think about this. I have PC1 hooked up to switch 1. And switch 1 is hooked up to switch 2, and PC2 is hooked to switch 2. So is this a straight line configuration or topology? And as traffic's coming from left to right from PC1 over to PC2, switch 1's trunk link that's going to switch 2, that's what I'm monitoring. So when I send out a ping, obviously I want to pay attention to the egress traffic. And that egress traffic obviously is going to be the request. The first thing is being sent out with a ping. I'm not worried about the replies. So as you can see here, I'm looking at traffic coming from PC1 over to PC2. Now, as you can see, this traffic coming from, where is it? There it is, 10.1.1.1 going to 10.1.1.2 is in VLAN 10. I mean, that's not great. It shows you right there, I'm in VLAN 10. Now, this is with the VLAN being VLAN 1. So we expect that. As I'm coming from here again, which is 10.1.1.1 and 10.1.1.2, as I'm coming across this again, the native VLAN is now VLAN 10. Well, if that's the case, I should not be seeing, if it's untagged traffic, I shouldn't be seeing 802.1q information, correct? So tonight I decided, you know what, I'm going to take it one step further. Why not? Because still I'm reading this in the documentation, and at this point I can't believe every piece of documentation I'm reading is wrong. I can believe documentation here and there is wrong. So what does this teach you as anyone who's a student? First of all, there's theory. Read it. Okay? Second of all, the theory that you read, don't believe it. Test it out in your lab. Third thing, if you feel something is wrong and you feel that you proved it, don't have a closed mind. Okay? When I started reading this again, I decided, well, let's really find a real test that can actually do this. Now, here's the lab that we're doing this on right here. Okay, but that doesn't really prove anything. I mean, we're looking at Wireshark. Wireshark is telling us that this is 8100 traffic. That's 802.1q. If it was IP traffic, it would just be 0x0800. But this is 8100. It's telling me that this is 802.1q traffic. So to me, it's tagged just like any other frame. But I decided, you know what? I have to do another lab to really prove me wrong or prove me right on this aspect. So I decided to set up an interesting lab here. And what we're going to do, and let me see if I can find a picture here. Okay, here it is. So let me go ahead and select all this, copy it. We'll bring it back over to our OneNote here. And we'll just go to a blank page. And we'll just slap this bad boy right up here. So here's our lab. Now, let's really pay attention to this lab here. One of the things that was discussed on Facebook just the other day was, you know, it's really comical when I read, comical to me anyway, when people are really frantic about whether they should go physical or go virtual. Guys, if you have the funds, by all means, go physical. I mean, as far as for your lab equipment, you can't go wrong. And in fact, it'll serve you much better. Trust me. One of the greatest things that I have in my lab, believe it or not, is a hub. Man, it has served me so much understanding for a lot of things. I just love my hub. That's all I can say. So here we have PC1. We're going to change the IP addresses of 192.168.1.1, 1.2, and 1.3. But we have to understand exactly what we're doing here. Instead of having our existing PCs, just like we had before, where here we had switch 1, and we had switch 2 sitting over here, and they were connected just like so. And we had our PC sitting over here, and another PC sitting over here, and they were connected so, and they were connected as so. And this is our trunk link, and there were .1q, and our native VLAN started off with 1, and then we moved it over to native VLAN 10. This is in VLAN 10, this was in VLAN 10. What I have done is I have taken this switch link and brought a hub into its place. And now this connects to here, connects to here, and that's what you see up here. So, one of the questions on Facebook was, well, if you hook it up this way, will it, I mean, is it still going to form a trunk between here and here? Well, remember that a hub is nothing more than a single broadcast domain. That's it. So, yeah, DTP information is going to come in here. Guess what's going to happen? It's going to flood out every port. It's a hub. Okay? And he's going to get the DTPs, and, you know, hey, it just, you know, the trunk's going to form. You know, one side is desirable, the other side is auto. So this is the test. This PC or router interfaces, they cannot read .1q. Now, yes, there's ways of making that happen. However, we're not making that happen. So in our lab, these interfaces, which really are routers, but I got them in as PCs in here, but these interfaces cannot read .1q tag information. So what will happen if that network card gets something that has a .1q in it? What do you think is going to happen? The PC will drop that frame. Just like that. It's like, I have no idea what this is. I can't read this. So here's the test. As traffic is transiting into this switch, It's going to be put into VLAN 10. As this traffic comes across and hits this hub, all right, now it's going to transit this trunk because this is a trunk link and it's a member of all VLANs. I've made no changes to the trunk, just the default settings. So as that traffic comes in this hub, that traffic is going to go in this direction and it's going to go in this direction. Now let's think about what happens with that. If it's tagged traffic, that traffic will get into this switch and we'll get to this PC, but this PC is going to drop it. He doesn't know how to read tag frames. Make sense? But if we ping and that traffic becomes untagged when it hits this switch port, then that traffic will still come into here, hit the switch, and hit the PC. Well, let's think about that. Okay? Now, PC1 is going to ping. Simple command. Ping 192.168.1.3. So, what is my source IP? 192.168.1.1. My destination IP is going to be 192.168.1.3. All right, this is my layer 3 information. All right, and we're not going to be really concerned with our, source and destination MAC. But here, we need to figure out if this is going to be tagged or not. Now, remember, our tag for .1Q is going to be actually embedded into our layer 2 information, so that's why I'm just sticking it here. So, is it tagged or not? As this traffic comes into here, we're going to be doing our forwarding based on. I remember we've already done it. We've already done an ARP at this point, so it's already in the ARP table, and we're going to forward based on the MAC address, getting us to what 1.3. So if that traffic comes in here as tagged, it comes in here again. PC, this will get it, but it won't be able to read it. If it's untagged, he will get this information. He will be able to read it. And guess what? What's going to happen? We have to understand that this is VLAN 10 traffic. So if this PC is sitting in VLAN 10, we will be able to ping this IP address. Now, if we put this in VLAN 20 and put this one in VLAN 20, we will not be able to ping this traffic. Let me rephrase that. If we put both of them in VLAN 20 and we're not able to ping this 192.168.1.3, what does that tell you? We're able to ping it when it's in VLAN 10, but we're not able to ping it when it's in VLAN 20. Well, that might give us a clue there, because obviously, if the traffic's coming in here untagged, this PC will get it and will be able to respond, which will prove to us if the traffic that any traffic that belongs to a VLAN that is the same as a native VLAN is tagged or untagged or not. Okay, so let's go take a look at our lab. Sometimes you got to be a little bit smarter than the technology. And what I mean by that is you have to take a look and find out how you can lab. Everything that you learn is labbable. That's just the way it is. Okay? Now, the only thing we cannot test is what? Well, ASICs, right? I mean, we really can't just get in there and just start figuring out, okay, is this ASIC really doing what they say it's doing? But as far as the technology and our traffic flows, remember, we are implementers. We're understanding the technology so we can implement. However, putting in commands is one thing. We need to understand what's really going on. So I'm going to look at router 1 here. And the first thing I'm going to do is show CDP neighbors. Alright, so I'm connected to switch 1. Now you're going to see some weird behavior here in a second here. Do show CDP neighbors. You see my hub sitting here. Now remember, we're sitting on switch 1. You see my router sitting here. That should make sense to you. But you also see router 3. Now, which is PC3, which is this one right over here. Okay, I didn't label these like I should, but 1.1 is 1, 1.2 is 2, PC2, and 1.3 is PC3, which really we're using routers for those PCs. You're seeing PC3 as if it was connected, and you have to understand this is where that hub, that single broadcast domain, can throw you for a loop. They're not directly connected. The switch does not know that it's connected to a hub. I mean, spanning tree knows that it's connected to a hub. But as far as this aspect CDP, it doesn't know that it's connected to a hub, and it's getting CDP packets from router 3 because it's a single broadcast domain. Every time PC3 sends out CDP information, guess what? It goes to the switch and goes to here and to this switch. So this switch believes he is directly connected to router 3, but again, weird behavior. He also believes that he's connected directly to what? Switch 2, because it's in the same broadcast domain. So now you're seeing CDP neighbors getting 3 CDP messages on the same interface. Alright, so a little strange behavior. Alright, now 3, but it's normal behavior. It's strange for us to see because we're not used to seeing it. It is normal behavior. Show CDP neighbors, we should see switch 1, switch 3, and router 2. Because of our broadcast domain and the hub itself. Now, on switch 2, show VLAN brief. Okay, we are in VLAN 20. All right, and FAO 24 does not belong in there. We don't need FAO 24. Or do we do show run? Do show run interface FAO 23. There's a trunk. I don't know why FAO 24 is up. I don't even think it is up. Do show IP interface brief. Include up. And it is not up, so we're not going to worry about it. You know what? I'm gonna get this out. I'm still gonna look at it. Because why is it coming up in oh, I'm sorry. I'm thinking of spanning tree. Sorry about that. That's fine. So anyway, it's in there. So do show VLAN brief. And what I mean by in there, it means this switch FAO2 is in VLAN 20. So we're going to switch that over to VLAN 10. Actually, no, we're going to leave it on VLAN 20. We'll come over here to switch 1, do show VLAN brief. And FAO1, which is going to PC1, we are connected into VLAN 20. Alright, so now let's take a look at our trunk. Do show interface trunk. We are trunked on our side, and notice that we're doing 802.1q. Notice that we are doing it for VLAN 10 and 20. And notice that we are in trunking status, and also notice that native VLAN is VLAN 10. Let's come over to switch 2, make sure we're still good to go. We always want to check both sides of our trunks. Do show interface trunk. And again, we are 802.1q. We are trunking status. Our native VLAN is 10, and we are allowing VLAN 10 and 20 across, or our active VLANs across these trunks at this moment. Now, from here, let's go over to router 1. Do ping 192.168.1.2, and we are successful. Now, let's do 1.3. Now, this would make sense because as traffic's coming in on VLAN 20, it's going to hit. Let's go through this. Because now at this moment, we are both now sitting in VLAN 20. VLAN 20, VLAN 20. As traffic's coming through and coming into this VLAN, it's going to be put in VLAN 20. This trunk will also receive that information, because now that interface is part of VLAN 20. That traffic will get tagged with .1Q because this is a trunk, okay? And that will come into this hub. The hub is just going to send it to both interfaces. It's going to come up to this switch port. This switch port is .1Q as well, and it's going to be able to read that traffic, and it's going to accept that traffic as VLAN 20 and bring it into this particular port here, and this PC will get this information and send its reply back, and goes back same way. Awesome. Now, we're going to keep this as VLAN 10. If this traffic is tagged, as you saw here, we have failed pings. That means if I put these in VLAN 10, if this is tagged, I should not be able to ping PC3. If it's untagged, I should be able to ping it. So, it's a simple configuration. All we have to do is go over here to switch 1, go into FA01, and say switch port access VLAN 10. Do show spanning tree VLAN 10. We want to make sure our spanning tree is good to go. I do have port fast on each one of those. Interface FA02. Switch port access VLAN 10. Do show spanning tree VLAN 10. Make sure our spanning tree is allowing our ports to forward, and we are good. FAO23, and I'm sorry, FAO1 on this side is forwarding, and FAO2 on this side is forwarding as well. So now let's go over here and let's ping 1.3 again, and look at that. So even though Wireshark is showing us that the traffic is .1Q traffic, now tell me this is not an awesome lab. This is what all of us should be doing. All CCNA candidates. You have a question, you don't read to get the answer. You don't do it. You use your equipment. This is what makes you more powerful and while you're learning this stuff. This is what separates you from your neighbor. So, even though Wireshark is showing us this will give you a strong ability to start going on forums and say, well, look, the traffic is still tagged. The native VLAN has nothing to do with matching nothing to do with the actual VLAN traffic. It still gets tagged. I can show you in Wireshark. And people will see this and say, huh, hey, he's right. But this type of lab, that's why having a hub in your lab does you some great justice. I've used a hub in a lot of scenarios to prove a theory for whatever I was trying to do. So this is interesting to understand. Now, of course, you read about this all the time. But when you start looking at Wireshark and start seeing this stuff, then you start to question some things. It's like, wait a minute. Wireshark is showing us very clearly that this is 802.1Q traffic. So this traffic must be tagged. Even though it's in the same VLAN as a native VLAN. But you got to admit, this is a pretty awesome lab, right? So, nonetheless, that's all I have, and I hope this helps you out to really understand and have a solid understanding that based on this lab, it shows us that traffic has to be untagged. It has to be, because this router can't read tagged information, or this PC interface cannot read tagged information. And when we had these in VLAN 20, native VLAN was 10, didn't happen. Put it in VLAN 10, that traffic came in and it was untagged. Because remember, this PC here, PC3, it's not in a VLAN at all. And so you have to understand that. It's not in a VLAN at all. It's stuck to a hub. Hubs don't have VLANs. Okay? So, nonetheless, that's it. And we'll see you next time.